The tunneling, there are two methods of tunneling. One is the cut and cover method, and another one is the bore tunneling. Okay, in the cut and cover method, the construction it involves excavation. It requires excavation equipment to dig a large trench or a rectangular hole in the ground, and which is then covered with by using concrete deck. Okay, so that is cut and cover method. The next one is bore method. Okay, in the bore method of tunneling, there are two types mainly. Depending upon the strata met with, there are two types. One is the tunneling through hard strata and the tunneling through soft strata. So when considering the tunneling through hard rock, again it depends upon what type of material that is met with during the tunneling operation. So hard rock, they are the fully supporting material, and soft soils, they require temporary supports during and after the construction. And this soft soil can again be classified into running ground, which are water bearing sand or similar cohesionless soil. So it requires instant support. Okay, they are called running ground. The next type is soft ground. Again, that also require instant support. So, like for example, if it is the tunneling is done through soft or clay soil, it's an example of soft ground that also requires instant support. Then there is another type called the firm ground, where the roof will stand for a few minutes and the sides can stand for much longer period. So for those type of material, the tunneling method required will be different. Then there is another type, that is the self-supporting ground, where the soil stands supported for a short period and for short length. So for example, sandstone, cemented stone, etc. So they are self-supporting, so they can stand supported for a given period of time. So depending upon the type of material met with during construction or during the tunneling operation, we will be deciding on what type of method we have to follow for that. So the choice of method, it depends upon the availability of the equipment, or mainly it depends upon the strata through which the tunneling is done. Then it depends upon the equipments that are available and the sequence in which this excavation process is carried out. So again depends upon the sequence of excavation. Again it depends upon the size of tunnel and also the type of ground. For example, the equipment, the type and nature of machinery available decides the adaptability of tunneling method. And the sequence of excavation, like what type of support mechanism are we going to provide after this excavation. So depending on that, again size of tunnel, if the tunnel is so wide, it requires more ground support as compared to a narrow tunnel. Then again it depends upon the type of ground, as I told you, the nature of soil or nature of strata met with, whether it is a hard rock or a soft soil. So the different boring techniques or bore tunnel, there are different methods followed depending upon these factors. Depending upon the type of ground, depending upon the equipment available, depending upon the sequence of excavation, and depending upon the size of tunnel, the different boring methods are decided. So in the case of rock, the different methods are full face heading, heading and bench method, drift method, and pilot tunnel method. Whereas in the case of soft soil, at every point of time after excavation, support need to be provided. So a shield is used before excavating the soil for supporting the excavation process. So this is the two main difference between the rocks. So rocks mainly we will drill and blast. Okay. We will drill the holes, and then we will fill that with the explosives and then we will blast it. So that is the tunneling in hard rock. So the different methods we will see in this video. Sequence of tunneling operation through hard strata. So these are the sequence of operation. So first one is construction of shaft. So what is this importance of this shaft? Okay, so in this figure you can see, so shaft, they are the vertical tunnels or wells or passages which reach from the ground surface to the tunnel. Okay, so these are the shaft. So they have different advantages. So it can be used for transferring the control point to the channel surface. Okay. Then again that can be used as a phase of channel during the channeling or boring operation. So there are two methods of the channeling operation, or I can say there are two systems of phase of operation for channel. One is the vertical shaft method, system of vertical shaft, like the one I have shown here, and the next one is the system of pilot channel. So in the case of vertical shaft system, the phase of attack, for example, you can see before the construction itself, these shaft will be installed. Okay, so how many phases of attack are there for this channel? So at a shaft, it can have two phases of attack. Okay, so you can have two phases of channel. So here in this shaft there is two phase. Here in this shaft there is another two phase. Then plus the entrance. Okay, so the entrance and exit of the channel is known as portal or adit. Okay, so depending upon how many number of shafts, the phase of attack also varies. So if, for example, if there are n number of shafts that are there, then 2n plus 2 phase of attack will be there, including the 2 ends or including the 2 portals. So first one is the construction of the shaft. Okay, so the surveying operation will be carried out above the surface. Okay, then that is transferred to the tunnel surface. So these points of shaft where we are providing this becomes a control points and its gradient, and again it can be transferred to the tunnel surface through this shaft. So first of all, the shaft need to be constructed. Then another system of attack is through the pilot tunnel. For example, if it is a very high mountain, okay, so then constructing the shaft won't be economical. So in that case, there are parallel tunnels which will be constructed by the side of the main tunnel. Then these pilot channels can be used as a phase of attack to the main tunnel. So these pilot channels are connected to the main channels by means of cross cuts. So these connection points are known as cross cuts. So the sequence of tunneling operation, first one is construction of shaft. Once a shaft is constructed, then the center line need to be transferred to the tunnel surface. And then we have to decide on which method of excavation we have to follow. So that need to be decided. It again depends upon the strata, it again depends upon the equipment that is available. So depending on all these factors, we will decide on the method of excavation. So if we are going for drilling and blasting method, we have to set up the drilling holes for blasting. So that is the fourth process. We have to set up drilling holes for blast. And then once these holes are set up, then explosives are to be placed inside these holes and then it is blasted. So the sixth operation is once explosives are placed inside these drilling holes, it will be blasted. So the blasting operation. So once blasting is done, there will be a lot of dust that is created. So that need to be removed, and also we have to provide ventilation for the workers who are working inside this tunnel. So we have to provide proper ventilation and we have to have adequate mechanism to remove the dust from the tunnel. Then next, this blasted material will get collected at the base of the tunnel, and that material is known as the muck. So there should be mechanism to remove the muck. So carting the muck at suitable places outside the tunnel is required, and later if it comes across groundwater, for example, the groundwater table is somewhere here. So at the time of excavation, it will be at every stage of excavation or blasting, the tunnel will get collected by the groundwater. Okay, so the groundwater will get collected at the tunnel. So that need to be removed. So pumping and removal of groundwater. Then we should have we need to provide adequate support inside this tunnel. Then once the support systems or supports are provided, then we have to line the inside of the tunnel, lining of the tunnel. Then once it is completed, we can open the channel for you. So these are the sequence of tunneling operations that are carried out. for tunneling in hard rock. So full face method, it is one method of tunneling through hard rock. Usually this method, why it is called full face method, because the entire face of the tunnel is tackled at the same time. Okay, it is not divided into head or bench, or it is not divided into drifts. The entire face of the tunnel, it is managed at the same time, so that is why it is known as full face method. And this type of tunneling is normally selected for small tunnels whose dimension is less than 3 meter. But nowadays with this sophisticated machinery, this can be used for large tunnels also. So what is being done is vertical columns are erected at the face of the tunnel, where a large number of drills are mounted on these vertical posts. Okay, which here you can see these are sliding drills. So these drills can be slide along this post or this vertical column, and then a series of holes will be drilled into the rock. Preferably they will be given in rows. Okay, so maybe 2 or 3 number of rows depending upon the height of this tunnel. That many number of rows of holes can be drilled into the rock. Once that is completed, these holes are charged with explosives and it can be ignited. So once it is ignited or blasted, these so the material will get collected at the bottom, and this blasted material can be taken or removed by means of providing tracks for carrying this mud or removing this mud from inside of the tunnel. So the advantage of this method is, since the entire section of the tunnel can be tackled at one time, this method becomes expeditious or speedy. Then another advantage is, since the entire column face is managed at a time, we can provide a track at the bottom of this tunnel, which can be used for carrying the muck from the tunnel. Okay, so mucking tracks can be laid for collecting the muck at the tunnel floor, and it can be extended further as the work progresses. And with the development of drill carriage or jumbo, drill carriage is what is known as jumbo, this method can be used for large tunnels also. So these are the advantages of full face method, and the disadvantage include it requires heavy machinery, and it is not suitable for unstable rock, because in this type the entire face is managed at the same time. So if the rock is unstable, then there can be chances of accidents. This method is mainly suitable for stable rock. It's not suitable for unstable rock, and normally it is adopted for small tunnels. So these are the details about the full face method. The next, these are some of the examples of full face method. You can see here. Okay. Next is heading and benching. So the entire tunnel is divided into head and the bench portion. So the top portion is what is known as the head portion. The top or the upper half portion of the tunnel is what is known as the head portion, and the bottom or lower half portion is known as the bench portion. So in this method, the heading of the tunnel is bored first, and then the bench portion follows that. Okay, so the heading portion, usually it lies 3.7 to 4.6 meter above the bench, and first the heading portion can be blasted and the muck will get collected in front of this bench portion, and then later it can be removed. So that is the process of head and bench method. Whereas in the full face method, the entire face of the tunnel is tackled at the same time. Whereas here, it is divided into two, the head portion and the bench portion. So first the heading portion, the blasting is done or the boring is done at the heading portion, and then the bench portion follows that. Okay. So in hard rock, the drill holes for the bench can be driven at the same time as the muck is removed. Okay, so during like these two processes can be done simultaneously. Once the top portion is blasted, the muck get collected, so we can remove the muck at the same time. We can use that time for drilling the holes in the bench portion. So the hard rock, it is more suited for the hard rock, which permits the roof to stay in place without any support. So the advantages, The work of drilling of holes for the explosives and the removal of muck can progress simultaneously. And this method requires lower quantity of gunpowder than the full phase method, because in the full phase method the entire phase is blasted at the same time. But here it is done at stages, so the lower quantity of gunpowder is required for doing this. So that is regarding the heading and benching method, where the head is the top portion and bench is the bottom portion. So first the heading portion is bored and later the bench portion follows that. Boring of the bench portion follows that. So this figure you can see here, it's an example of tunnel that is bored by this heading and bench method. So first the head portion, here you can see it has proceeded up to here, and then the bottom portion can be done. So this is the excavation, the direction of excavation. So top heading is done, the tunneling of top heading is done, then the bench portion follows it. Then the next method is the drift method. So drift, they are small tunnels of dimension 3 by 3 meter, which is driven into the rock. And later this drift, the section of this drift is widened in subsequent process till it equates that of the tunnel. So initially a small drift will be constructed or driven, and later this can be widened to the dimension of the tunnel. So that is regarding the drift method of tunneling. So depending upon where this drift, the first drift is driven, there can be different methods. That is, the first drift is driven at the bottom, it is bottom drift method, or the first drift, if it is driven at the top, it is top drift method, center drift, or it can be side drift. A number of drill holes are provided all around the drift, and these are filled up with explosives and ignited, so that the size of the drift expands to become equal to the required cross section of the tunnel. So that is how this drift method works. The position of the drift again depends upon the local condition. It can be provided, as I told you, it can be provided at the center, top, or bottom, or at the sides. So, field experiments have shown that the central drift is the best choice, as it offers better ventilation and requires lower quantities of explosives. So once the center drift is driven, then expanding of this requires less amount of explosives. So from field experience, it is found that center drift is the best suited one, whereas side drift is suited when we can provide this side drift, or we can use this side drift for providing timber support. So here we can provide timber support for the roof. So if the roof is unstable, we can go for side drift. So first the side drift can be constructed, and then shuttering can be provided at these side drifts. Then later we can go for boring the top portion. So that is regarding the drift method of tunneling. So the advantage, it includes if the quality of the rock is bad, or if it contains excessive water, then it is detected, then we can take corrective measures. So we don't know what is inside the tunnel that we are going to excavate, right? So material we are not aware of. So when we are going with this drift method, initially this drift will be of smaller dimension, will be driven first. So if there are some issues inside, then that can be detected in advance, and corrective remedial measures can be taken. At the same time, we can check about the alignment also, if we are going in the proper direction. If the alignment is not proper, then there can be chance like the two ends of the tunnel won't come and meet at the same point, because usually the tunneling, when you're doing the tunneling, the tunnel driving procedure, we start from two ends. For example, this is a tunnel connecting point A with point B. Okay, so the driving procedure, we start from these two ends. Okay, so if the alignment is not proper, for example, if you see this in the plan, if the alignment, we start from here and here, if the alignment is not proper, they may go into different directions and these two ends will meet. Okay, so in order to avoid this, the alignment should be proper. We should have surface control points, and these control points, the gradient as well as its coordinates, need to be transferred to the the tunnel surface. So for that we are using shaft. Okay, later this shaft can also be used as the uh, uh, phase for operation. Okay, so this shaft initially can be used for transferring the center as well as the alignment or the gradient or the coordinate of these points can be transferred to the tunnel surface through this shaft, because initially when doing the surveying we are doing this at the surface, and later we need to transfer those points to the bottom of the tunnel, and these points where we are doing this survey, these points are known as control points, which controls the alignment of the tunnel. Okay, so when we are doing by the drift method, we are initially drilling this hole. Thereby, we can see whether we are going in the proper direction. If not, we can take corrective measures. So that is regarding the drift method. And if there is some problem associated with the strata inside, for example, if you come across a water table, or if the condition of the rock is bad inside, okay, we cannot expect always the homogeneous strata. Sometimes the type of material that we are seeing outside may not be the material that is inside. So if the condition of the rock or the condition of the strata is not uniform, that also can be detected when we are doing this drift. Okay, so these initial tunnels will help you give an idea about the strata that we are going to deal with, and also regarding the water table. So if some problems are there, then corrective measures can be taken to rectify that. Okay. So that is regarding one of the advantage of drift method. And another advantage is once the drift is constructed, they can be used as a ventilation for the further excavate or boring process. Okay, for further boring process, this drift that we initially constructed, it act as a ventilation. Okay, and the quantity of explosives required is also less, because we start with a small drift and then later it's expanded. So the quantity of explosive required will be less. And as I told you, when side drifts are provided, this can be used to support the roof. And the disadvantage is when here we are doing this we are dividing the entire process into segments of each drift, so it is a little bit time consuming. It is time consuming process, as the excavation of the main tunnel gets delayed till the drift is completed. Okay. And the cost of drilling and removing the mud from the drift is high, as the work has to be done using manually operated power driven equipment. Okay. So these are the details about the drift method of tunnel. So this is a photo of the Himmelbach tunnel, which was built in 1999 during its construction. This are the side drifts, left and right drifts. So once this left and right drifts are completed, then we can go for boring the center core. Okay, so this figure you can see already the left and right drift have expanded much beyond the center drift, and then we can go for boring the center core. Next is the pilot tunnel method. It involves digging of two tunnels. Okay, one is a pilot tunnel, another one is a main tunnel. So this method normally involves the digging of two tunnels. One is known as a pilot tunnel, another one is the main tunnel, and these two are connected by means of cross cuts. Okay, so the cross section of the pilot tunnel will be much smaller than that of the main tunnel. Usually it is 2.4 by 2.4 meter. The pilot tunnel is driven parallel to the main tunnel and is connected to the center line of the main tunnel by means of cross cuts at adequate points. The main tunnel is excavated from a number of points, and the pilot tunnel offers the following advantage. It offers the following advantage. It helps in removing the mud from the main tunnel. So the mud that is blasted, or the blasted material from the main tunnel, can be removed through this pilot tunnel. And again, this pilot tunnel can be used as the phase of operation for the main channel. So once you are starting the blasting from here, this pilot tunnel, at each cross cuts there will be a point which it comes and meet with the main tunnel. So this can be used as a point of attack. to bore the main tunnel. And it also helps in providing proper ventilation and lighting for the main tunnel. So these are the advantages of pilot tunnel method. And here you can see a prototype showing main tunnel, pilot tunnel and service tunnel. So all these will be laid parallel to each other and there will be interconnection between them, and these interconnection are known as cross cuts. So after construction, this pilot tunnel can be used as a service line also. The perimeter method of tunneling, also known as the German method. In this method, the excavation is carried out along the perimeter or periphery of the section. For example, if you want to construct a circular tunnel, then the excavation process is carried along the perimeter or periphery of the section. So that method is what is known as the German method or perimeter method of tunneling.